You know, there's a massive industrial-scale operation happening in the world of AI, pretty much right under our noses. It's a heist, but the target isn't gold or cash, it's the actual intelligence of the most advanced AI models out there. And today, we're going to break down exactly how this grand theft is being pulled off.
So this whole story just blew wide open when the AI safety company Anthropic, the folks who made the Claude AI, dropped a total bombshell. They announced they'd found these coordinated industrial-scale campaigns that were designed to illegally steal their model's capabilities. And we're not talking about a handful of hackers here. This was a calculated, systematic effort on a scale that's, well, is pretty hard to wrap your head around. So what does staggering scale actually look like? Well, it looks like this. Over 16 million illicit exchanges. That's right, 16 million times these organizations were probing and just harvesting information from Anthropic's Claude AI. They used thousands of fake accounts, all of it completely against the terms of service. This wasn't some casual user messing around. This was a factory floor operation designed for one thing: theft. Now, Anthropic was able to identify 3 specific China-based AI labs with what they said was high confidence. As you can see right here, the biggest player by a long shot was Minimax. They were allegedly responsible for over 13 million of these exchanges. Then you've got Moonshot AI with over 3.4 million and DeepSeek with more than 150,000. And according to Anthropic, these aren't just little startups, they are major players in the global AI race who were systematically siphoning capabilities from a competitor. Okay, so we know who was involved and the just insane scale of this operation. But how on earth do you actually steal an AI's intelligence? Well, the technique has a specific name, and it's the key to this whole story. It's called a distillation attack. Let's break down exactly what that means. At its core, a distillation attack is basically a way of training a smaller, weaker AI model by just feeding it the answers from a stronger proprietary one. You're pretty much forcing the powerful AI to become an unwilling teacher for your own student AI. This lets your model learn all these advanced capabilities incredibly fast, and for just a tiny fraction of the original cost and time. So here's how the heist actually goes down, in 3 key phases. First up is querying. The attacker just bombards the target model with a massive systematic number of prompts. Next is harvesting. They carefully save every single prompt and the model's exact response. And finally, distillation. This huge new dataset of question and answer pairs is then used to train their own model, which effectively clones the target's abilities. And this is a perfect way to think about it. You've got the large, incredibly expensive teacher model, like Anthropic's Claude, which has billions of dollars of R&D poured into it. The attacker uses that teacher to generate all these high-quality examples, which they then use to train their own, smaller, much cheaper, student model. The student learns the teacher's knowledge, its style, its core capabilities, and it becomes a functional, low-cost clone. Now, knowing the technique is one thing, but pulling it off at a scale of 16 million exchanges without getting caught, that requires a really sophisticated playbook. These labs didn't just casually stroll through the front door. They used some advanced tactics to hide what they were doing. I mean, they deployed a full suite of cloak and dagger tactics. We're talking thousands of fraudulent accounts, often exploiting programs that were meant for schools or startups. They hid their identities and where they were coming from using commercial proxy services, and they built what Anthropic calls hydrocluster networks. These sprawling, multi-headed systems designed to spread out the traffic. So if one account gets banned, boom, another one instantly pops up to take its place. But here's the crazy part. The main weapon here wasn't some complex piece of hacking software, it was the prompt itself. A single prompt like this one looks totally harmless. But when you automate tens of thousands of variations of it across thousands of accounts, all targeting a very specific skill like data analysis or coding, a very clear pattern of industrial-scale theft starts to emerge from all that noise. Look, this sophisticated theft is way more than just a case of corporate spying. The stakes go far, far beyond one company's bottom line. This is really about global technology competition, and even more importantly, about national security. See, when a model is cloned through distillation, it doesn't copy over the safety features. Companies like Anthropic spend enormous resources building in safeguards to stop their AI from being used for dangerous things, like designing bioweapons or launching cyber attacks. These cloned models are basically stripped bare of all those protections. And that means these powerful, unprotected AI capabilities can just proliferate out into the wild.
These raw, unguarded abilities can then be plugged into military and intelligence systems, and that could potentially let authoritarian governments use them for offensive cyber operations, really sophisticated disinformation campaigns, or mass surveillance, all without the original safety rails in place.
These attacks also directly undermine policies like U.S. export controls, which are there to maintain a strategic lead in critical technologies. Instead of having to build their own innovation from the ground up, foreign labs can just steal state-of-the-art capabilities. They can close the technology gap through theft instead of legitimate research.
Now, this all sounds pretty dire, I know, but it is not a one-sided fight. This is an active arms race. For every new attack method, the industry is developing and deploying new defenses. This isn't a problem you just solve once. It's a continuous, ongoing battle of wits.
And the core defensive philosophy is actually fascinating. Since you can't completely prevent these attacks, an AI that can't be prompted is useless. The goal shifts from total prevention to pure economics. You have to make stealing the model so expensive, so difficult, and so time-consuming that it becomes cheaper for them to just license it legitimately. So in response, Anthropic is basically building a digital immune system. They're deploying advanced classifiers that can automatically spot the subtle patterns of distillation attacks. They're actively sharing what they find with other labs and cloud providers to map out the whole threat. And they're strengthening their access controls to make creating those thousands of fake accounts a lot harder.
And this really reflects a broader industry playbook. Companies use things like API rate limiting to slow attackers down to a crawl. They enforce strict user verification to get rid of the anonymity, and they deploy these complex anomaly detection systems that can spot the bizarre, scattered patterns of a data harvesting bot versus the more natural behavior of a real human. It really is a multi-layered defense.
But all of these attacks and all of these defenses really point to a fundamental, maybe even unsolvable tension that's right at the heart of AI development.
This quote from the security community really says it all. The main function of a large language model, its very ability to answer your prompt, is also the main way it can be stolen. If people can use your model, people can find a way to steal from it.
And that forces this constant, inevitable trade-off. Every single step a company takes to make a model more secure, like adding strict rate limits or identity checks, it adds friction. It makes it a little less useful for legitimate users. And every step to make it more open and accessible also makes it more vulnerable. It's a tightrope that every single AI company has to walk.
Which leaves us with this crucial final question. As these systems get exponentially more powerful and woven into, well, everything we do, is it even possible for them to be both open and useful and completely secure from this kind of theft? That's the challenge that's going to define the next chapter of the AI arms race.